Now let us discuss the IoT communication model. So we will discuss the IoT communication model and its comparison with the standard web application communication. So we will see IoT stack as well as web stack, and we'll see what are the differences between IoT stack and the web stack. So when you see the IoT communication mechanism, you will see that the base of IoT communication is derived from wireless sensor network. So as we see in case of wireless sensor network, here also you will have IEEE 802.15.4 MAC sublayer and IEEE 802.15.4 physical layer as reduced function layers for the IoT stack development. So on top of the IEEE 802.15.4 MAC and physical layers, we will have the other layers utilized for creating the network and the routing capabilities and the data applications for the data communication. So when you compare with the standard web application, you will see that in a standard web application, we will have full functional data link as well as physical layer, which is based on IEEE 802.3, that is nothing but Ethernet, and IEEE 802.11, which is the Wi-Fi communication. So if you compare the lower layers, IoT is based on reduced function layers and the web applications are based on full functional layers. Now, when you talk about the internet layer, since the standard IPv6 routing layer cannot understand the IEEE 802.15.4, we utilize 6LoWPAN as sublayer in the internet layer, which acts as an interface between IPv6 routing layer and the IEEE 802.15.4 MAC sublayer. So to interact between standard IPv6 layer and the 802.15.4 layer, 6LoWPAN has to be implemented. While in case of standard web application, the data is shared through standard data link layer. There is no need to have the interfacing sublayer for the data communication. So that's why at the internet layer, you will have either IPv6 or IPv4 for the data communication. Now at the transport layer, you will utilize either UDP or DTLS for the data communication. DTLS stands for Datagram Transport Layer Security. So this will help in building the security layer so that the data can be securely transmitted using IoT devices. In case of web stack, we have TCP as well as UDP capabilities because it is full functional layer. So the information can be shared from the bottommost layer to the transport layer without any challenge. While in case of IoT, since the data transmission has to be very fast, the most of the time the IoT communication happens over UDP where acknowledgement is not needed. On top of the transport layer, we will see various application layer level protocols such as COAP, MQTT, XMPP, and AMQP being implemented, which help in sharing the data from transport layer to the software applications. At software application level, we will utilize various data formats such as binary, JSON, or maybe CBOR. CBOR stands for concise binary object representation. This we utilize especially in those cases where the data bandwidth is a constraint and we need data to be transmitted using low bandwidth. Then the CBOR offers very small data message size so that the information can be shared with the other application without any challenge. On top of the data format, you will see various IoT applications built which will utilize the data format to share the data. We will also have the device management because the IoT device needs to be properly configured and controlled. So device management is also another important application to be built in the IoT stack. While in case of web application, we can utilize standard web applications which we see normally in our day-to-day working. So those web applications will utilize standard HTML, XML or JSON formats for the data communication, and then various standard application layer level protocols such as HTTP, DHCP and so on for the data communication. How the information flows in IoT? So in the base, you will see various sensors and actuators which are responsible to acquire data from the field. They will convert that data into digital format, and then this information is shared with various IoT devices which will pack the data in a particular protocol and share the data to the end servers or maybe the cloud applications. So for that they can utilize various data processing protocols such as Zigbee, Z-Wave or broadband over power line and so on. So these IoT devices will be responsible to carry out the data handling, and then they might send data directly to the cloud or may utilize the IoT gateway to share the data. So if there is an IoT gateway, the role of IoT gateway is to consolidate the data coming from various IoT devices and then share data with the end applications. So here the IoT devices will only do the data processing at local level and then share the data to the gateway, which will further connect data to either cloud application or the remote server application using various communication mechanism such as GPRS, Wi-Fi, or maybe utilizing various communication protocols such as MQTT, COAP, and so on. When the IoT device does not have the IoT gateway nearby, then IoT device has to be configured in such a way that it can share data directly to the remote application or maybe the cloud. So for that, the most commonly utilized architecture is the RESTful API. So RESTful API is nothing but an architectural style that defines a set of constraints to be used for creating the web services. So API is nothing but application programming interface where the IoT device utilize the REST architecture to share the data with the remote application. So the web services that conform to the RESTful architecture or the RESTful web services provide the interoperability between the computer systems and the other internet connected devices. The REST compliant web services allow the requesting system to access and manipulate the textual representations of the web resources, that is the data which is being shared by using a uniform and predefined set of stateless operations. So RESTful API offers the constraints under which the API has to be configured so that the data can be shared with the end application. Now, at the cloud or maybe at the end application level, there you will see various analytics applications running and the data storage is happening so that the information which is received from the field can be further processed and then the action is taken based on the information received from the field. Let's see the example how the IoT software application development happens. So this is a typical example of Microsoft Azure based IoT development platform. Here the devices, sensors and actuators are configured using COAP SDK and using various gateways and the machine to machine communication. The information is shared with the Microsoft Azure cloud and then either the information is processed at the cloud or maybe it is further connected with the remote applications using RESTful APIs so that the information can be properly processed and then the processed information in the form of command goes back to the devices such as the robotic arms or maybe cars or on any other devices which will be responsible to act upon the information or the command shared by the remote application. So these devices are made internet enabled using the COAP SDK. So the sensors and actuators which are part of these devices will be made IoT enabled so that they can send data as well as receive commands for the activity. Let's see a typical example of a smart home solution. In the smart home solution, we will see a home is having various IoT devices that may be the smart appliances which are IoT devices or the air conditioner, thermostat and so on. So all the devices are internet enabled and they interact with the external world through their home controller which acts as a gateway. So similar to a smart home which is in one house can be replicated in multiple houses. So this will be a cluster of the residential houses which are having the devices IoT enabled. Similarly, the commercial buildings can also have the various sensors which are IoT enabled. So these will communicate over internet to the remote applications. Say for example, if you want to deploy the demand response program, so these devices will share the real-time measurement information to the remote applications and these applications will process the data for realizing the demand response program. So until unless you have the devices internet enabled, it is very difficult to share the data with the application and take action based on the information acquired in the field. Now let's understand what are the various gaps in the market with respect to the deployment of Internet of Things. So first is the technology. Since IoT is a new concept, the technology is keep on changing and the standardization of technology is still not being taken up, and this is causing a challenge in maintaining the device as well as data interoperability in the IoT space. Communication is another challenge because IoT devices are built on various communication platforms. So when the communication technology changes, the IoT device also has to be reconfigured and make it compatible with respect to the new communication technology. So for example, right now the IoT devices are compatible with either 3G or 4G communication, but the moment we see 5G network deployment, all these devices have to be communicating using 5G or the NB-IoT communication. So the communication also is a challenge for the IoT device deployment. Since the IoT requires machine-to-machine communication, the standard 3G and 4G communication has the limitations in implementing the IoT related data communication. Next is IoT framework. Since the IoT framework is not a standard framework available as of now, it is keep on changing. So because of the continuous changes, the deployment of solution will also suffer. So we do not have a standard IoT framework available as of now on which we can do the development of IoT devices. IT-OT convergence is another challenge since IoT devices fall under the IT area while the data acquisition falls under the OT area. The convergence also is required at IoT level so that it can utilize best of both domains in the technology implementation. Innovation and analytics, the IoT is continuously evolving, so there is lot of work needs to be done for better data acquisition, data processing, and doing the data analytics. Now, what are the various challenges and opportunities in the IoT space? Operational challenges. We have the challenges related to connectivity with other devices. It has challenges with respect to compatibility and longevity, adoptions of standard within IoT, privacy, regulation, intelligent analysis, and immature ecosystem. So IoT is still evolving. That's why the overall ecosystem in IoT space is still not mature. What are the various technology challenges? Cyber security challenge. Since the IoT devices are very vulnerable to cyber attack and there is very less work done to make the IoT devices secure. So cyber security is another technology challenges as of now in Internet of Things. Communication network, as we discussed, the machine-to-machine communication is not enabled in the existing communication technologies. Machine-to-machine communication also travels in the same channel with the voice data. So lot of delays and interferences happens. So when we have the 5G data communication, we may have the possibility of having the separate machine-to-machine communication channels for the implementation of better IoT network. Power consumption is another challenge because these have to be the always power devices. Sometimes in the field, these IoT devices cannot be always powered on. In that case, the power consumption will be the constraint for the deployment of IoT devices. Data which we receive from the field and the data which is being processed by IoT devices are complex data, and because of this data complexity, the data interoperability is also a challenge in case of IoT devices. Technology framework is still not being freezed because it is still evolving. So the moment the technology framework changes, the lot of rework is required to be done for making it compatible with the technology framework. Reliability is another challenge. Then operating system platform is another technology challenges because these devices are built on top of the wireless sensor network capabilities, which is a challenge in the current technology space. What are the opportunities which we can get from the IoT deployment? We can get better visualization because the data acquisition is fast. The IoT device can acquire data as well as it can take actions locally and globally. So both types of intelligence can be built in the IoT device. Better price discovery, since the data is acquired from the field in real time, we can check the possible congestion of the networks, and accordingly we can take action for the better locational marginal prices of the electricity at various nodes. Better capacity augmentation, since we can deploy the demand response programs using IoT devices, the capacity augmentation can be better utilized. Demand response management can be implemented with the help of these devices. We can use these devices for the intelligent operations. These devices help in real-time monitoring and control. At the same time, also we can have the better electric vehicle integration into the system. Since EV is also a connected device, or we can say the IoT device, the data and the status received from electric vehicles can help in proper scheduling of the power availability.